Alright guys, in this lesson we're solving logarithmic equations. And there's two major types of logarithmic equations. First type is every term has a log with it. And the second type is every term doesn't have a log with it. Some people call it type 1 log equations where every term has a log with it. I personally don't do that. I just talk myself through every process to see, hey, does every term have a log with it or not? And we'll deal with the situations if they do and if they don't as we go along. So first, let's just kind of dive in. I actually like to start with number 2. Number 2 makes this process with every term has a log with it like totally makes sense. So first question, you've got two terms here. You got your pink term and you got your blue term. They're on different sides of the equal signs, but would you believe that they both have a log with it? And in all of these, they'll be the same base. Like this is log base 2, log base 2. If they don't have the same base, this process isn't going to work, but all of ours will. And you got to ask yourself, does every term have a log with it? And that answer in this case is yes. And is it ready to where it's log equals log? Like the pink side is 1 log and the blue side is 1 log. Is it log equals log? Like do I have to condense anything like what we did last class period? And that answer is no. Well, if every term has a log with it and you got it to log equals log, here's how simple it is. We call it drop the old logs. Like the logs can basically go away and the arguments are equal to each other. And in this case, we get this going away and this going away, and your arguments are x and 12, and then you'd end up solving for x. But hey, this one's so simple it's done. X would have to be 12. And what we have to do is check to see if there's any extraneous answers. Let me refresh your memory on what an extraneous answer was. If you had a problem like this back in geometry where they wanted you to solve for x, and you did the math with the Pythagorean theorem, you'd get down to x squared equals 25, and you'd solve, and x algebraically could equal plus or minus 5. But we know that we have to throw that negative answer away because that's what's called extraneous. It doesn't make any sense. Well, in logarithmic equations, we possibly could have extraneous answers, because here's what has to happen. When we substitute back in to the original problem, the argument must be positive. Can't be 0, can't be negative. It must be positive. And if we put 12 back in here, that's going to work. So 12 is our solution. So that's kind of neat. Let's try some more. We're talking ourselves through it. This is a logarithmic equation. You can see the equal sign. It's got an equation with it, and is logs involved. The question is, does every term have a log with it? Well, here's a term because the argument is in parentheses, right? So there's a term. It's got a log base 4 with it, and here's a term. It's got a log base 4 with it. So since every term has a log with it, we can get rid of the logs, drop the logs, and set the arguments equal to each other. And then solve for x. So we're back to Algebra 1. I'll subtract 2x from this side, add 1 over here in this case, and I get a possible solution of x being 4. But I must go back and check into the original problem to see if the argument comes out positive. And we don't require that you show any work on this whatsoever. We just need to check to see if that's going to happen. So it doesn't really matter which one you go into first. They just have to come out positive. So if I put 4 in for x, I could mentally do this. That would give me a 12 minus 1, which is positive. That's 11. And if I put 4 in over here, that'd be 8 plus 3, which is 11. So I got a positive argument back both times. That means 4 checks, and he is our solution. So in these logarithmic equations, every term has a log with it. As you can see in this guy, you got an equation. Boom. There are logs involved. Cool. Does every term have a log with it? Yes. So we can set the arguments equal to each other. There was no need to condense either. It was log equals log. And yay! Welcome back. Quadratic equation. To solve this, we usually like to get it equal to 0 and see if he can factor. So I'm going to keep this number in front of x squared positive, subtract this 3x over, and get this guy equal to 0. And pretty much most of these will be easy factorable because the a is 1 and we've designed it to where they are factorable. If they're not factorable, you either complete the square or use the quadratic formula. But let's find two numbers that multiply together to be -4 and add together to be -3. So that'd be 1 and 4, and if the 4 was negative, isn't that our winner winner chicken dinner? So we'll factor him. because it's easy factor, we don't have to go through any of that work, then we could solve for x with the zero product property. X could be -1 or 4. These are possible solutions. We must now go back and check into the original problem to see if any of the arguments come out negative. It doesn't matter about these answers, it matters about the arguments. So you've got two arguments. You've got your pink argument and you've got your blue argument right here. Would you believe that the blue argument is a little more simple to deal with than the pink one because nothing's being squared? Well, if we substitute in the -1 right here, boom, would you realize that's not going to work because we get a negative argument in that case. 3 times -1 is -3. So this guy is extraneous. He's not a solution to this situation. If we put the 4 in, again, I'll put it in here. I get a positive argument back. So far, so good. But now you got to go check in the other argument. All the arguments have to turn out to be positive. The reason why I was done after this guy is because if you get a negative argument, you're done. It can't even be 0. It's got to be positive. So if I put 4 in here, that was a winner. If I put 4 in here, 4 squared is 16. Take away 4, which is still positive. So 4 is a solution for us. We'll put him in the solution set. So every term had a log with it. We didn't have to condense. We dropped the logs, set the arguments equal to each other, solved, and checked. Didn't show any work on the check either. Just got to check for extraneous answers. So this one is of a very similar nature. It's a logarithmic equation. Every term has a log with it because this argument here is in parentheses, so I can get rid of the logs and set the arguments equal to each other. And smells like we got to do another set of factoring. So keep this a value positive so you can easy factor him. When he's a +1, you just find two numbers that multiply together to be meow and add together to be meh. And it looks like we're dealing with a 3 and a 5, and we need the 5 to be negative. If you need help factoring, don't be afraid to ask us a question. Keep it equal to 0. X could equal -3 or a +5. And again, we're not automatically throwing out the -1. We're going back to see if it makes the argument positive or not, because you got to have a positive argument. -3 is not going to do that. This argument comes out negative. If I put 5 in here, I get a positive argument of 10. That's good. But then I got to go check it over here. 5 squared is 25. Take away 15, which is still positive. So this guy checks. Our solution is just 5 on this guy. So every term has a log with it. As you can see here, now we've got a weirdo situation here. He's got a log with it. That's good. He's got a log with it. That's good. And he's got a log with it. So the question is, does every term have a log with it? And that's a big fat yes. But over meow, you can't have like logs being added together. We need to condense this down in this case. So that's why we learned all those properties of logarithms last time. When they're adding logs together, you can multiply those arguments together. So we can take ourselves to 27 times the shui. I believe that's 81. I don't know what's going on with my calculator here. 81. So I can rewrite this guy. This dude over here is log base 7 of 81. I totally condensed him down. And over here, instead of writing the 2 log base 7 of x, remember another one of them properties of exponents is any of these guys that are in front can come up to be an exponent on the argument. So kind of doing all that stuff we practiced last time for a reason, and now every term has a log with it, and you got it to log of something equals log of something. Got to get it to log equals log. Now you can set the arguments equal to each other. And x squared equals 81. This is quadratic, but we don't need to factor it because there's no x's to the first. We can just do the square root property. And x could equal 9 or -9. Remember the old plus or minus when you square root somebody. And now to check for extraneous answers, we got to go back to the original problem. You can't use this guy, can't use this guy. Got to go back to the OG, and we've got to check to see if we get any negative arguments or 0 for an argument. The argument must be positive is the easiest way to say it. So if I put 9 in here, boom, that's a winner. 9 is positive, he's going to check. If we put negative 9 in here, negative 9 makes this argument negative in that case, so that is not good. And people, they have a good question. They say, but doesn't that get squared because of this 2 up here? It's the way that the problem is typed in the original guy. And negative 9 is not going to make this guy work. Now, if they'd have this, if they'd have it typed like this, then negative 9 would check because you'd get a positive argument. So it's so picky, guys. So picky. The idea is go back to the original problem and see if the argument is positive. And negative 9 is not going to give you a positive argument. So tough. Alright. So this one we had to condense. There'll be lots of those like on your homework that you'll have to condense also. Over here, we do not have to condense because we've got an equation. Every term has a log with it, and it's already just 1 log of something equals 1 log of something else. So we will drop the logs, if I could write correctly, and set the arguments equal to each other. And this is another one of those where you got x squareds, and it's got x's to the first, so we want to try to get this guy equal to 0 and factor it. Keep this home slice right here. Let's not use red. Let's use orange. Keep this guy a positive 1, though, so we can easy factor him. So I'm going to move these guys over. So they got an x squared, and then to move this guy over, it's going to be plus 11x. And to move this guy over, I need to subtract 2, so that's going to have me with the 28. 30, take away 2. And now, trying to find two numbers that multiply together to be 28 and add together to be 11. I'll pause for a second so you can figure that out. It's 4 and 7, guys. 4 and 7, do that. And that would factor to be x plus 4 times x minus 7, plus 7. And that means our solutions, x could be negative 4 or negative 7. And now it looks like you'd want to throw both of those away because they're both negative. That's not the case at all. We got to go back to the original problem and substitute these guys in. You got 2 arguments to choose from, and they're both kind of complicated, you know, so I think the pink one's a little bit easier to deal with than the orange one, though. So if I put this negative 4 in here, I don't even really need to do all the math. If I just notice the signs, it'd be a negative times a negative, which is positive, and add 2 to it, that's going to turn out positive. So that's good. I got a positive when I put it into the pink guy, but now I got to go over and check the orange dude. If I put a negative in here and it's getting squared, isn't that going to turn out positive? Plus 30 more, that's positive, so this is going to check. And you know, by the same logic, because all we dealt with was the sign of this guy being negative, this guy's going to check also, so they both work. So beautiful. Negative 4 and negative 7. We'll put them in a solution set. It doesn't matter what order they go in either, but they both make this a true statement. So every term had a log with it in all of these. Sometimes you got to condense. Sometimes you don't need to. These we usually do just fine on. It's the next dudes. It's so simple, but yet we get so complicated by the time we're ready to take our test of how to deal with these. These are definitely logarithmic equations. You can see the equal sign, bada boom, and it's got a log with it, but not every term has a log with it. Here's a term over here. Let me do a little erasing. So you got your equation in pink. You got a term right there, 3/2 in blue, and if I can get my highlighter back, I also have this term over here. This term in green has a log with it, log base 36, but the blue one doesn't. So what's our move? Our move right here is rewrite exponentially. I will totally think that it's just a good idea to just put notes. Here's the steps of what you want to do. It's so confusing. Just write it in one simple phrase. Rewrite, if I could write, exponentially. And this is the stuff we did on basically day 1. Day 1 of this chapter, where you guys ate it up. You're like, oh, that's so simple. You just turn it from log form into exponential form. So remember, when it's in log form, to change it that way, you got to realize who's the base. Is it the 36? Is it the x? Or is it the 3/2? I think we all know that it's the 36. Then we need an exponent right here. And remember, that's the guy that's exiled all by himself on one side of the equal sign, and that'll equal the argument. Remember doing that from the first day of this chapter, where you took it where it was a log form and put it in exponential form. Well, now we can totally solve this for x. This is 36 to the 3/2 power equals x. And we spent a lot of time in a chapter with no calculator solving this. Remember, power over root. So this is basically saying for us to do the square root of 36, which, tricky, is plus or minus 6, and that's going to be cubed equals x. We have used the root. Now we got to use the power and realize we're going to get two answers back. 6 cubed is 216, or negative 6 cubed is negative 216. You have two different possibilities on this guy. And we got to go back and check to see if there's any extraneous answers. What are you checking for? If the argument is positive. If he's positive, you're good. If he's not positive, you're not good. So putting 216 in here, boom, that'll give us a positive argument. Putting negative 216, nope, can't have a negative argument. So the solution to this logarithmic equation is just 216. So we were doing those with no calculator in a chapter before. You will have your calculator on this portion of the test. This is not the non-calculator stuff, but it's just pretty simple. If you only typed it in, you just get 6. You don't realize that you're going to get plus or minus 6 in that situation, so watch out. All right, let's try another one of those. Here's how we're talking ourselves through it. Okay, it's an equation. You just got to see that from the start. Are there logs involved? Because next time we're going to learn some stuff about where there's not logs. We're going to solve exponential equations. But are there logs involved? Yes. Does every term have a log with it is the next question. That's a no. This guy over here does not have a log with it. So since there's logs, get it to log equals number and rewrite exponentially. So base to the exponent equals the argument. And this is a little bit different than before. What we're trying to do is solve for x. He's not over here. We don't raise anything to a power. We can't take x to the 3/2 power. What we want to do is get rid of this 3/2 power, and you'll raise both sides to the reciprocal power. The reciprocal of 3/2 is 2/3. So we'll raise both sides to the 2/3. I think you should show those baby steps. The reason why that works is because if you do power to a power, these numbers multiply to be 1. So you'd be getting like x to the 1st, which is what we're trying to solve for. And let's do this no calculator. We do the root first. Who's the cube root of 27? It's 3. It's not even plus or minus 3. You only do that with even powers. And then that's being squared. So x is going to equal 9. There's nothing to go back and check because you're checking to see if the argument comes out positive. And we already know the argument. It's 27, so this guy has to check if we do our math right. Now, if you do your math wrong, it might not check out. But if you do everything right, he checks. So weird. Let's try another one. I'm going to ask you the questions. It's an equation, so that's a given, right? Are there logs involved? Yes. Does every term have a log with it? Nope. This term over here does not have a log with it. Coffee break. So what we have to do is condense and rewrite exponentially. Let's condense first. Over here, la 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 la, they've got logs being added together. That means we need to keep the log with it. Don't let the log disappear, but multiply these arguments together. So what you got is you got x minus 9 and x being multiplied together. So I'm going to distribute that. That's going to be x squared minus 9x. See how the distribution happened right there. And that equals 2. Notice, though, that the log base 6 still had to be there. So here's our argument. These guys got multiplied together. That's all that we did. And now that I got it to log of something equals a number, it's time to rewrite exponentially. Because there's this goofiness involved, people forget all about that. They just think they can take this argument and set it equal to 2. No way, Jose. Rewrite exponentially. The base to the exponent equals the argument. You cool with that move? We rocked that so good. Just be careful with that. Rewrite exponentially. Then I just scratch this guy out and call him 36 because that's what he really is. And notice this is a quadratic equation. We want to try to get him equal to 0 so we can factor him. So lots of crazy math stuff going on with these logarithmic equations. Finding two numbers that multiply together to be negative 36 and adding together to be negative 9. So we can try through that whole list, and it turns out to be that it's 3 and negative 12. So we will factor this to be x plus 3 times x minus 12, and we know that x could equal negative 3 or 12 in that scenario. Got to go back and check where in the original problem. So checking for a positive argument, negative 3, not going to work right there. Makes that argument negative. If we put 12 in, that's good. Makes that positive. Got to check the other guy. 12 minus 9 is a 3, so that is positive, so he checks in that scenario. So 12 is our solution. Holy macaroni, look at all the math concepts in one problem right there. Let's do it again, talking ourselves through it. Are there logs involved in this equation? Yes. Does every term have a log with it? Nope. This term right here does not have a log with it. So let's get it to log equals number. We have to condense this guy. Because they are adding these logs together, we will multiply those arguments. So we still have the log base 8, but to condense this, we'll multiply and get 8x squared. 2 times 4x squared is 8x squared. Then the equals 1. The only thing that we have done is change this one side right here and condensed him down. Now we rewrite exponentially. Base, exponent, equals argument. Simple stuff. Take this to that power. It's going to turn out to be 8 anyway, but you can't square root yet. You got to get x squared all by himself. So the reason why we're not factoring is because there's not an x to the first. There's only x squared. So dividing both sides by 8, boom, x equals 1 in that case. Then square root both sides. X could equal 1 or negative 1. I like to write it this way instead of plus or minus because I got to go check them both. And if I check 1, I got to go back to the OG and check the argument. Man, 1, that'll make that positive right there, so he checks. If we put negative 1 in there, negative 1 squared, because it's being squared literally in this problem, that's going to turn out positive, so they both check. So that is neato burrito. Holy cow. We are moving fast. If you need to pause and take a break, do so. But we're cooking. All right. Next guy. Are there logs involved? Yes. Does every term have a log with it? No. So, do we need to condense? Yes. And then we'll take it from there. So, because they are subtracting these arguments, that means, they are subtracting these logarithms. That means we condense with division. Who's ever got a positive in front of him is upstairs. Whoever's got a negative in front of him is downstairs. And the log base 10 is still there, and the equals 0 is still there. All we did was condense it first. Now, rewrite exponentially. Base to the exponent equals argument. And then 10 to the 0th power is really 1. And now we need to realize this is a whole group right here. You don't have to write it in parentheses, but it's probably better if you do write it in parentheses. And to solve this equation, we'll get rid of this divide by 2 minus y by multiplying by 2 minus y. If this was anything by the 1, you'd have to distribute it through there, but 1 times this, it still gets distributed, but it's just 2 minus y, and that'll equal y. So multiply both sides there. Add the y over. And then solve. Y could equal 1 in that case. So go back and check the OG, see if there's any extraneous answers. 1 being substituted in makes that positive, so that's good. If you put 1 in here, you're still positive, so he checks. it is possible to have no solutions. You know, like if it failed and that was our only choice, we could have none. So, all right. Number 12, I don't like that problem. We're not going to do that one, so omit this guy. That's the gist of it right here is we might have to do some condensing, we might have to do some moving, so I've done all of these for you. It's time for you to do them on your own. Let's try number 13. Talk yourself through it. Pause the video and either every term has a log with it or every term doesn't have a log with it. See what you can do on 13. Pause it, give it a shot, and then join me. Okay, in this guy, I hope you give it a shot. Every term does have a log with it. You see the left side, this because the arguments in parentheses, that's got a log with it, that's got a log with it. So we can realize it's already log equals log, didn't have to do any condensing, set the arguments equal each other, solve for x, and I got a possible x value of 3. But now we got to go and substitute him in to see if there's any extraneous answers. Argument must be positive. And if we put 3 in here, 3 minus 3 is 0, which is not positive. So nope, can't have him, meaning he was the only choice we got, so our solution is empty. We can put the brackets with nothing inside, or you could put the circle with the slash to it. Just don't put them inside each other. It doesn't work that way. It's either like this or it's like this. So that didn't work. And then the last guy here, let's give him a shot. Talk yourself through it. Does every term have a log with it? If so, condense and drop the logs. If not, condense and rewrite exponentially. So give it a shot. Let's see what happens. Okay, not every term has a log with it. This guy doesn't, so I did need to condense, so I multiplied those arguments together. Great. Condense, cool. Now that's still its log equals number. Rewrite exponentially, so 3 to the second equals the argument. Then, since it's quadratic, it's got x squareds and x's. I'm going to get it equal to 0. Remember that was a 9 right there by subtracting that over. Factor. Boom, 1 and negative 9 were my two numbers, so it's easy factorable. Then I solve, got to go back and check. Boom, put negative 1 in there is going to be no bueno, so negative 1 is out. Put 9 in, 9's cool here, 9's cool here, it comes out positive, so 9 is our solution. So solving log equations, talk yourself through it. Please let us know if you have any questions. Have a good one.